The sun unleashed its fury and Earth was caught in the crossfire. A solar storm so massive it bent the rules of nature. Auroras painted the skies over Florida and Mexico, places where they should never appear. But behind this light show lies a hidden danger. This wasn't just a spectacle, it was a warning. Satellites struggled, power grids flickered, and scientists issued urgent alerts. The culprit? A sunspot 16 times the size of Earth, still lurking and poised to strike again. What happens when the sun decides to push even harder, and are we prepared for what's coming next? The recent solar storm was no ordinary event. It was born from an astronomical powerhouse known as AR 3664, a sunspot so massive it could swallow 16 Earths whole. This giant dark patch on the sun's surface didn't just grow, it exploded. Within days, it unleashed multiple X-class solar flares, the most powerful kind, alongside a barrage of coronal mass ejections (CMEs). These combined forces are rare, and when they strike together, they create storms capable of reshaping the way we live. But what makes solar flares and CMEs so dangerous? Imagine a solar flare as a lightning strike. Instantaneous, blindingly powerful, and fast enough to reach Earth in just over 8 minutes. A CME, on the other hand, is like a tsunami in space, slow-moving but devastating when it collides with Earth's magnetic field. Together, they are a one-two punch that can disrupt satellites, communications, and even threaten power grids. NASA and NOAA didn't just stumble upon this storm. They've been monitoring the sun's behavior using state-of-the-art tools like the Solar Dynamics Observatory and the Parker Solar Probe. These instruments don't just take pictures. They track solar eruptions in real time, providing us with early warnings. Even artificial intelligence is now being trained to predict these events, offering humanity a fighting chance against the sun's unpredictable wrath. This isn't the first time solar activity has upended life on Earth. The Carrington event of 1859 sparked fires in telegraph offices and lit up the night skies with auroras as far south as the Caribbean. Imagine that level of disruption today with our world dependent on satellites, GPS, and internet connectivity. This storm was just the opening act, hinting at the sun's peak activity in its 11-year cycle. But as we'll soon discover, what comes next might be even more unpredictable. To understand the true magnitude of the recent solar storm, we need to examine the core phenomena driving it and the broader implications for modern society. Solar storms are not isolated cosmic events. They represent the sun's immense power interacting with Earth's fragile systems in ways both awe-inspiring and potentially devastating. The recent storm stemmed from AR 3664, a sunspot of extraordinary size and activity. Sunspots like these are cooler, darker regions on the sun's surface where intense magnetic activity builds up over days or weeks. When this energy is suddenly released, it results in solar flares and CMEs, the primary drivers of solar storms. Solar flares are bursts of electromagnetic radiation that travel at the speed of light, reaching Earth in just over 8 minutes. These flares can cause immediate disruptions to radio communications, GPS systems, and even pose a risk to astronauts aboard the International Space Station. Imagine an air traffic control system losing communication with pilots or emergency services experiencing outages during critical moments. These are not hypothetical risks but real vulnerabilities exposed by solar flares. CMEs, by contrast, are slower moving but far more dangerous over the long term. These massive clouds of charged particles travel through space and can take days to reach Earth. When they collide with Earth's magnetic field, they induce geomagnetic storms which can disrupt power grids, damage satellites, and create stunning auroras. But this beauty has a cost. Electricity grids can experience overloads, leading to blackouts like the one in Quebec in 1989, when 6 million people lost power. The stakes are even higher today with our heavy reliance on interconnected systems like the internet and global communications. To put this in perspective, we can compare the recent storm to historical events like the Carrington event of 1859. This geomagnetic storm was so powerful it set telegraph lines on fire and caused auroras as far south as the Caribbean. While this was a spectacle in the 19th century, a storm of similar magnitude today could cause catastrophic damage. Imagine a scenario where undersea internet cables are damaged, severing communication between continents. GPS disruptions could halt shipping and aviation industries, while power outages could plunge entire nations into darkness for weeks or months. Experts estimate the financial toll of such an event could exceed $2.6 trillion, with recovery taking years. But it's not just about the risks. Solar storms also reveal humanity's growing dependence on fragile technology. While we've made significant advancements in monitoring and forecasting space weather using tools like NASA's Solar Dynamics Observatory and NOAA's geostationary operational environmental satellites, our preparedness still lags behind the sun's unpredictability. These storms highlight the need for more resilient infrastructure, better early warning systems, and international cooperation to mitigate their impacts. The question we must ask is not whether a storm of Carrington-class intensity will occur again, but when. As we approach the solar maximum, the peak of the sun's 11-year activity cycle, the frequency of such storms is expected to rise. What would happen if we faced a Carrington-class event today? How would governments, industries, and individuals adapt to a world suddenly thrown into technological disarray? Solar storms are reminders of our place in a dynamic and often volatile solar system. They challenge us to innovate, prepare, and respect the forces beyond our control, ensuring that we can continue to thrive even in the face of the sun's most dramatic outbursts. The sun's activity affects every corner of our modern world in ways many don't realize. The recent solar storm was a vivid example of how fragile our technological systems can be. But why does this matter to you? It's not just about spectacular auroras. It's about understanding the invisible forces that shape the systems we rely on daily. Solar storms are not just space weather. They can disrupt supply chains, disable energy grids, and even impact the financial world. For instance, stock exchanges and cryptocurrency markets heavily rely on precise GPS signals for transaction timing. A prolonged disruption to these systems could trigger widespread economic instability. Similarly, modern agriculture increasingly depends on satellite-driven technology for monitoring weather, soil, and irrigation. A solar storm could jeopardize global food production, affecting millions. There's also the growing concern over space travel. With plans for long-term human missions to Mars and beyond, solar radiation poses a critical challenge. A storm of this magnitude could expose astronauts to dangerous levels of radiation, halting exploration and putting lives at risk. Preparing for solar activity is as much about protecting life in space as it is about safeguarding life on Earth. This topic also matters because it highlights the interdependence of technology and nature. As we approach the solar maximum, industries from aviation to renewable energy must adapt. Even electric vehicles, which rely on battery technology, could face challenges if grid stability is compromised during a storm. The bigger picture here is resilience. Solar storms aren't just scientific curiosities, they're a test of how prepared we are to protect the systems that sustain modern civilization. How we respond now will determine whether we thrive or falter in the face of the sun's unpredictable power. At stake is not just technology but the broader ability of society to adapt to natural forces beyond its control. The sun's increasing activity reminds us that even with modern advancements, we remain vulnerable to cosmic phenomena. Solar storms challenge industries that pride themselves on resilience. Can renewable energy systems designed to combat climate change withstand the unpredictability of geomagnetic forces? The question becomes especially critical as solar and wind energy adoption expands globally. The stakes extend into global infrastructure. Undersea internet cables, which form the backbone of international communication, could be disrupted by geomagnetic interference. This would isolate continents, cutting off trade, diplomatic connections, and even essential humanitarian responses during crises. The cascading effects of such a disruption would ripple through economies and societies alike. Additionally, solar storms could test humanity's readiness for future space colonization. As private companies and nations invest heavily in establishing lunar bases and Mars missions, the ability to monitor, predict, and shield against solar radiation will determine how and when we can safely live beyond Earth. The societal risks go deeper, exposing our dependence on digital systems and global connectivity. Events like solar storms force governments, industries, and individuals to rethink resilience, pushing innovation in ways that protect not just physical infrastructure but societal stability. The real question is whether we are prepared to act before we are forced to react. Sunspot AR 3664, one of the largest in the current solar cycle, stands out not only for its size, 16 times that of Earth, but also for its rapid growth and intense activity. Its behavior hints at the unpredictable cycles of the sun, particularly as it prepares to re-emerge in a few weeks due to the sun's rotation. Scientists speculate it could remain active or even intensify, potentially triggering new waves of geomagnetic storms. Recent research suggests sunspots like AR 3664 may lead to sunspot clustering, where one active region sparks the formation of others, prolonging solar activity. This raises the possibility of extended periods of heightened solar risk. Instruments like coronagraphs and solar observatories are closely monitoring its magnetic alignment for signs of future eruptions. Beyond immediate impacts, AR 3664 offers a glimpse into the deeper dynamics of the Sun. Questions remain about whether such sunspots stabilize the Sun's magnetic field after eruptions or leave it more vulnerable to future instabilities. Understanding these patterns could significantly improve space weather prediction models. For space exploration, AR 3664's potential recurrence poses critical challenges. Solar radiation from similar sunspots could threaten astronauts on missions to the Moon or Mars, forcing new strategies for shielding and mission planning. Satellites in orbit are also at risk of cumulative damage, accelerating the need for robust radiation-resistant designs. AR 3664 is not just a fleeting event but a reminder of how much remains unknown about the Sun's deeper cycles. Its return could reshape our understanding of solar activity and redefine how we prepare for its impacts. The stakes for science, technology, and exploration have never been higher. What if everything we thought we knew about solar storms isn't quite right? The recent event triggered a storm of not just particles but also misinformation. Social media lit up with dramatic claims. Auroras in Florida mean the apocalypse is near, the sun is collapsing. While these statements may seem laughable, they reflect a deeper truth, the fear of the unknown. Solar storms have always sparked myths, from ancient beliefs about auroras being omens of war to modern conspiracy theories about the sun's activity heralding global disaster. During the recent storm, viral posts fueled unnecessary panic with images of exaggerated auroras and claims of imminent technological collapse. But beneath the misinformation lies a critical question. How much of the fear is justified, and what are we still missing about the sun's behavior? Scientists monitoring sunspots like AR 3664 face their own unknowns. Why do certain sunspots like this one grow so rapidly? Could the unprecedented auroras in nonpolar regions signal a shift in solar activity patterns? And most importantly, what will happen when AR 3664 rotates back into Earth's view in a few weeks? The possibilities range from quiet decay to an even more intense eruption, and no one can yet predict the outcome with certainty. Adding to the suspense are the tools scientists are relying on. Real-time data from NASA's Solar Dynamics Observatory and advanced AI models have improved predictions, but they're still far from perfect. The sun remains a puzzle, one that refuses to give up its secrets easily. As researchers grapple with new theories, the stakes continue to rise, leaving us to wonder, could a future storm push humanity's resilience to its limits? For now, the answers remain elusive. But the sun isn't waiting. Its activity is building toward the solar maximum, and with each passing day, AR 3664 is closer to reappearing. When it does, will we be prepared, or will it bring a storm even the best scientists couldn't foresee? One thing is certain. The next chapter of this story will be anything but predictable. Key telescopes like NASA's Solar Dynamics Observatory and ESA's Solar Orbiter provide real-time solar data, but gaps remain in long-term forecasting. The Parker Solar Probe and Inouye Solar Telescope aim to bridge these gaps by studying sunspot dynamics and solar eruptions closer and in more detail. Radiation protection for deep space missions is also a challenge. Magnetic shielding and advanced materials are being developed to safeguard astronauts on Mars missions. On Earth, undersea internet cables and renewable energy systems require upgrades to resist geomagnetic disruptions. Global coordination is essential. Proposals for an international space weather network could unify data and response strategies, ensuring faster, more accurate mitigation. Overcoming these challenges will push innovation in space science, infrastructure, and global cooperation. As the sun's activity continues to intensify, the question isn't just what it's capable of but how prepared we are to face it. The recent solar storm was a glimpse of what the sun can do, but what happens when the next one is even stronger? Could it expose vulnerabilities we haven't even considered or spark discoveries that redefine our understanding of the universe? The sun is unpredictable, and AR 3664 is just one chapter in a much larger story. What secrets will the next solar cycle reveal, and could our closest star hold answers to questions about stars across the galaxy? Let us know your thoughts. Have you ever seen an aurora or experienced disruptions caused by solar activity? Stay tuned because the story of the sun is far from over.